Hello and welcome back, or welcome to our Chapter 4, Part 1 of Managing and Maintaining Your PC. In this chapter we're going to focus on the power supply, which provides power to all other components inside the computer case. Several types of power supplies are available, and the form factor of the computer case and motherboard drive which type of power supply can be installed into our systems. Therefore, we begin the chapter by discussing the form factors of computer cases, motherboards, and power supplies. To troubleshoot problems with the power system of a PC, you need to have a basic understanding of electricity. You're going to learn about the measurements of electricity and the form in which it comes to you as a house current. The chapter then covers how to select a power supply and how to protect the computer system from damage caused by electrical problems. Next, we'll discuss how to take a computer apart and put it back together. And then finally we'll talk about ways to detect and correct problems with the PC's electrical systems, including how to change a defective power supply. This chapter is the first in a group of chapters to learn how to service computer hardware. We begin with the electrical system because it's so important that you know how to protect yourself and the equipment against electrical dangers as you work. In later chapters, you'll want to apply these safety skills learned in this chapter. Other skills learned in this chapter, such as taking a computer apart and putting it back together, will be useful to know in the future chapters, in which you will exchange other computer parts besides just the power supply itself. This chapter is about a computer's electrical system and power supply, such as the one shown here behind me. However, because motherboards, power supplies, and a computer case are often sold together and must be compatible with each other, we begin by looking at these three components of an interconnecting system. When you put together a new system or replace components in an existing system, the motherboard, power supply, and case must all be compatible. These standards that describe the size, shape, and major features of these components so they work together are called form factors. And when you're deciding which form factor to use, the motherboard drives the decision because it determines what the system can do. After you've decided to use a certain form factor for the motherboard, you must use the same form factor for the case and power supply. Using a matching form factor for the motherboard, power supply, and case ensures you that the motherboard fits in the case, that the power supply cords of the motherboard provide the correct voltage, and the connectors match the connections on the board, that the holes in the motherboard align with the holes in the case for anchoring the board to the case itself. The holes in the case align with ports coming off the motherboard. For some form factors, wires for switches and lights in the front of the case match up with connections on the motherboard itself. The holes in the power supply align with holes in the case for anchoring the power supply to the case. There are different types of form factors. So when you're selecting a computer case, motherboard, and power supply, choose a design that fits for its intended use. For instance, you might find that you need a high-end tower system, a rack-mounted server, or a low-profile desktop. When you understand the intended use, you can then decide which form factor that you're going to use. The current and better-known form factors are listed here behind me in the table. Now these form factors are discussed next. The first one I want to discuss with you is the ATX form factor. Now ATX stands for Advanced Technology Extended. It is the most commonly used form factor today. It is an open, non-proprietary industry specification originally designed by Intel in 1995 and has undergone several revisions since then. An ATX motherboard measures up to 12 inches by 9.6 inches. The CPU and memory slots sit beside expansion slots so that the full-length expansion cards don't bump into the CPU or memory modules. The original ATX form factor had case fans blowing air into the case, but earlier revisions of the form factor had fans blowing air out of the case. Now blowing air out of the case does a better job of keeping the system cool, and as I've said many times before, heat is the enemy of the computer. The first ATX power supplies and motherboards used a single power connector called a P1 connector and had 20 pins. Now these pins provided a positive 3.3, positive 5, and positive 12, and a negative 12 volts, and an optional and rarely used negative 5 volts. The electrical requirements for motherboards changed over time as new technologies made additional demands for power. When processors began to require more power, the ATX version 2.1 specifications then added a 4-pin auxiliary connector near the processor socket to provide an additional 12 volts of power. Now a power supply that provides this 4-pin 12 volt power connector is called an ATX 12 volt power supply. Later boards changed the 4-pin 12 volt power connector to an 8-pin connector that provided more amps for the processor. Later, when PCI Express slots were added to the motherboards, more power was expected again, and a new ATX specification 2.2 allowed for a 24-pin P1 connector, which is backward compatible with a 20-pin P1 connector. The extra 4 pins of the connector provided a positive 12, positive 5, and positive 3.3 volt pins. Motherboards that support PCI Express and have the 24-pin P1 connector are sometimes called the enhanced ATX boards. Now, here you can see a 20-pin P1 power cord from the power supply and a 24-pin P1 connector on the motherboard. Okay. This next figure shows the pin outs for the 24-pin power cord connector, which is color-coded to the wires from the power supply. And the 20-pin connector is missing the lower 4 pins. In this photo and diagram, you can see that you can see all that in this photo and diagram. Now, if an operating system supports this feature, it can turn off the power to the system after the shutdown procedure is done. In addition, BIOS setup can be set up to be configured to cause a keystroke or a network activity to power up the system, like a wake on LAN. When a user presses the power switch on the front of the case while the computer is on, the operating system goes through a normal shutdown procedure before powering off. There are several variations of ATX motherboards, and the less popular one is the Mini ATX, which is a smaller ATX motherboard, measuring 11.2 by 8.2 inches. Now, it can be used with ATX cases and power supplies. Another less popular one is the extended ATX motherboard that can be up to 12 by 13 inches, and it's used in rack-mounted servers. The next one I want to discuss is the micro ATX form factor. It is a major variation of ATX and addresses some technologies that have emerged since the original development of ATX. It reduces the total cost of the system by reducing the number of expansion slots on the board, reducing the power supply to the board, and allowing for a smaller case size. The micro ATX motherboard will fit into a case that follows the ATX 2.1 or higher standard. A variation of the micro ATX is the Mini ITX. Now this form factor is smaller than the micro ATX and designed for smaller systems such as a home theater system. Next I want to discuss the Flex ATX, which is a variation of the micro ATX. It allows for maximum flexibility, giving it the name Flex ATX, and therefore can be a good choice for custom systems. The Flex ATX motherboard can be up to 9 inches by 7.5 inches, and the motherboard costs less, has fewer features, and is smaller than the micro ATX board. The Flex is commonly used in slimline and all-in-one cases, but it can fit into any Flex ATX or micro ATX or ATX case that follows the ATX 2.03 or higher standard. Next form factor I want to discuss is the BTX or Balanced Technology Extended form factor, designed by Intel in 2003 for flexibility, and it can be used by everything from large tower systems to those ultra-small systems that sit under a monitor. It was designed to take full advantage of serial ATA, USB 2.0, and PCI Express technologies. The form factor design focuses on reducing heat with better airflow and improved fans and coolers. It also gives better structural support for the motherboard than did the ATX. The BTX motherboards use a 24-pin power connector that has the same pin-out arrangement as the ATX 24-pin P1 connector. The BTX form factor can also use one or more auxiliary power connectors for the processor, fans, and lighting inside the case for really cool looking systems. Now because the 24-pin connectors are the same, the BTX motherboard can use an ATX power supply. And in the case that we're showing here, you'll notice how the processor is sitting immediately in front of the intake fan installed in the front of the case. This intake fan, together with the exhaust fan on the rear of the case, produces a strong wind tunnel effect over the processor, making it unnecessary to have a fan on the top of the processor itself. Now also notice that here that the memory modules and expansion cards fit into the slots parallel to the airflow rather than blocking the airflow as they sometimes do with the ATX form factors. Airflow in a BTX system is also designed to flow underneath the BTX motherboard. Now a BTX case, say by Gateway, with a motherboard installed, here the BTX case has fans on the front of the rear to force air over the processor heatsink. Now notice that here in the figure, the green encasement that directs airflow over the heatsink, also notice that the vents in the front of the case panel to help move the air. Now when the BTX form factor was first introduced, it was expected to replace the ATX. However, it has not gained as much popularity with those who build custom systems as was first anticipated. Now even though Dell and Gateway have both produced their own BTX brand name systems, it appears ATX will continue to be the most popular form factor. The NLX form factor, the new low profile extended form factor for low-end personal computer motherboards, was developed in Intel back in '98 to improve on an older and similar form factor called the LPX. Now in these systems, the motherboard has only one expansion slot in which a riser card, also called a bus riser or a daughter card, would be mounted. Now the expansion cards are then mounted on the riser card, and the card also contains connectors and for floppy and hard drives. The riser card in the LX motherboard is on the edge of the board, which differs from the LPX boards that had the riser card near the center of the board. The NLX standard applies only to motherboards. The NLX motherboards are designed to use ATX power supplies. An example of an NLX system is shown here behind me. Now that concludes this portion of form factors. Now be sure to move on to the online course management system and complete any assessments or labs that have been posted for this particular section. Then come on back here and we'll have a discussion on the computer cases themselves. See you.